So good morning, ladies and gentlemen. Very warm welcome to all of you to Embedded World 2023 here in Nuremberg. It's my pleasure to give this introduction here. My name is Axel Sikora. I'm chairman of the Embedded World Conference and part of the organizing team behind. We start the conference and the whole event, exhibition and conference with a keynote. We have 3 keynotes in total, but of course the first day is special day. And for this reason, we also have a special guest here, who is Daniel Cooley, CTO from Silicon Labs. And this is a great honor for us to have you here. Daniel serves as CTO and Senior Vice President, Technology and Product Development, being responsible for the company's overall research and development strategy and execution. He has a long 18 plus years Silicon Labs history starting, and this is very nice, of course, also for me as an engineer, starting as senior design manager, so coming from, with a technical background, has a bachelor in electrical engineering from University of Texas, has a master in electrical engineering from Stanford, has several patents, and when browsing through his CV, I found 2 more positions that I found remarkable. He's board member of Open Hardware Group. This is something I didn't expect at first. And also he's board member of the Austin Symphony Orchestra, and as a music lover, I also very much appreciate that. So again, let me welcome you, Daniel, to the stage and give you the stage for your intro or keynote to Embedded World 2023. Thank you very much.
Thank you. Good morning, everyone. My name is Daniel Cooley, and I'm the CTO for Silicon Labs. We make the wireless chips and software that connect embedded systems to the internet. Much of my life centers around this technology, and I'm excited today to talk about our connected future. We're going to do this in 3 sections. First, the what, why, and how of the IoT. Second, the massive effects this is having on the global economy. And third, the things we need to do differently going forward to take this to the next level. We're going to start with a look back first. In 2011, 2 things happened that year. First, we all may remember Ericsson published a landmark white paper talking about a prediction of 50 billion connected devices by the end of the decade. Second, Apple launched the iPhone 4S. This was the first smartphone with native support for the latest Bluetooth standard, Bluetooth Low Energy. I remember these events well, as Silicon Labs was ramping up investments in wireless connectivity at the time. The prediction from IDC really stretched the imagination. To imagine a world with 50 billion wireless devices was kind of crazy. After all, smartphone adoption was still on the rise, and no wireless technology had ever been deployed to this scale. And then for Apple, their vision of the smartphone as more than the phone and more than the pocket computer, but as a hub to connect to the real world, to transfer data back and forth between embedded systems on a scale we had never seen before. That also really stretched the imagination. And I was like, what is this really going to look like? And I dug up an old article from Engadget that predicted internet-connected cats. And as a cat lover, I thought that was pretty fine. So what happened? Where are we now, and what does it look like? Well, we are now at a world with 35 to 40 billion installed IoT devices. And according to IDC, we'll hit that 50 billion unit number not long from now. Really within the next couple of years. I call that a pretty good prediction from Ericsson, going from 0 to 50 billion, and we're only there 2 years from now. And of course, we got our internet-connected cats. And I want to dwell on that one for a moment, because to get that cat online, really big things had to happen. There's really 4 of them. We're going to focus most of the talk today on 1, but there's really 4. The first is that we have almost unlimited kind of cloud computing infrastructure that wasn't built back in 2010. AWS was there and Azure was there, but it wasn't nearly as big as it is today. Second, you have to have data networks, the mature data networks that can get a lot of data from anywhere to anywhere reliably at low cost. We had 3G, but 4G and LTE were still on the rise, and this idea of transacting data all the time, anytime, was still fairly new. Third, we had to have kind of ubiquitous smartphone and connected computers in our pockets every single day. And I remember the first BlackBerries, but that was not really, the idea of the cell phone coming later. And fourth, of course, and this is where Silicon Labs comes in, we had to have billions of low-cost, powerful connectivity solutions anywhere that can be adopted by almost any segment, not just in PC, mobile, tablets. So these four markets, data centers, mobile, PC, IoT, embedded, are linked, and it's worth taking a look at them together. I would say that after embedded's going online, it is really the largest computing platform on the planet. We typically don't think about embedded as a computing platform in this way because it's so fragmented and is been offline most of its existence. But we ship more volume to more customers in more segments, and we do this with maximum constraints on what we do in power, in storage, in compute, in bandwidth, cost, lifetime. We really deliver phenomenal technology in a very nice, tight solution that means this stuff can literally go anywhere. And it's already all around us. These processors in this room, there's hundreds of them surrounding us. And most importantly, they're about to go online. So the data centers connected in the 80s, PCs from the mid-90s to about the mid-2000s, and of course smartphones the decade after that. What's most exciting about embedded computing to me today is that it's going online. This idea that any CPU out there is a candidate for connecting to the cloud. Going all the way back to 2010, we've been talking about this. Well, it's happening now, and we literally have billions of these things surrounding us. It's a very powerful concept, and one that's going to continue to play out over the next 10 to 20 years. So if many of us, myself included, will spend the rest of our careers designing generation after generation after generation of this IoT technology. But I think it's important to ask, or to just level set with this audience, like, what do I mean by IoT? Because everybody has an IoT business, right? Every company says they're IoT. For me, it's a really simple idea. Take something, take anything, break the air gap, connect it to the cloud. It's that simple. And for many devices that are out there, this is really the last step, adding connectivity in. They were already rich embedded systems with compute, with sensing, with transducing, and bringing the cloud connection was just the last piece. Example, the power tool behind me. But for other applications, there was nothing before. The first step was connectivity. And when you do that, take something as simple as a shelf label, a pallet, applications where there were no electronics before, you connect it to the cloud comes down into the device, spreads the silicon, spreads the sensing, spreads the software. We're starting to see many end markets with billions of potential sockets out there where there was nothing before. Once connected, these devices take on a completely different paradigm, completely different kind of mindset around developing and building them. But it starts with connectivity. Without that connectivity, everything is different. It really sets the data free. This constant, persistent, bidirectional communication from the cloud down to the device is, to me, one of the most important parts. And I have yet to come across an industry, an application, a segment, or a customer who is not just thinking about putting this into their products, but asking themselves how fast they can go. And they're contending with lots of things. They've got chips, they've got software, they've got integration in the cloud, they've got to do new business models and use cases around it. And I've stopped counting the reasons why. These are just some examples of what our customers are doing with this technology, whether it's enabling new use cases or consumer experiences, adding more security, safety, better energy and health, retail. We'll go through some of these examples in a bit here. But when we were starting this journey at Silicon Labs more than 20 years ago, we kind of asked ourselves, like, how far is this going to go? Every time I think about that, I get it wrong. If you ask me today, I'm probably going to get it wrong. It's just always bigger and bigger and bigger, because as the barrier to entry comes down, these things are going everywhere. So how has that journey looked? This is Silicon Labs' journey from early silicon to complete platforms. And there's lots of companies here today at the show and like Silicon Labs that are doing this, and it's been a ground-up evolution over this time period. What we're finally seeing is that the embedded spaces have purpose-built platforms for them, not repurposed platforms from mobile, from automotive, from PC or tablets. We started this business almost 20 years ago, very humble, 8-bit MCUs connected to sub-gigahertz low data rate wireless transceivers. And our customers began talking about this, connected future. We'd actually been talking about it for a very long time, but they started implementing it. And generation after generation of technology, we've seen more processing, more connectivity, more security, more machine intelligence. As these barriers were falling on the chip side, similar barriers were falling on data center, AWS, Azure, data center compute, cloud computing, the data networks, the mobile computing that was out there. We've all been building this together, and the IoT has arrived. 50 billion units is probably undercalling this thing as big as it's going to get, and you'll see some predictions later. But you can imagine a world with hundreds of billions of these devices, and without these kind of platforms, it would be impossible. And as the IoT gets really, really big, it's going to have a lot of effects on our economy. And in preparation for this, and in the research that I was doing, I kind of bucketed the effects into kind of 3 pillars here: high impact, high permanence. This is one way. Once you start adopting this technology, you don't go back. And then the sheer pervasiveness that it's going to have all around us. I'd like to explore these, and they play off each other. This is not necessarily completely independent, but I'll explore this with you guys next. So first on impact. There's a lot of ways to measure impact in this world. McKinsey published an article or a white paper predicting that by the end of this decade, we'll see IoT technology, the impact to the global economy, anywhere from 5.5 trillion to 12.6 trillion US dollars. When you do the projections of the global GDP, this represents anywhere from 5 to 10% of the global economy is now resting on the technology that we're all building. Our customers, maybe, in the end, customers don't even think about it as technology. They're just taking the next step in automation, the next step in efficiency, the next step in safety. But without that connectivity, it wouldn't happen. And these are just fantastically large numbers, thinking about trillions of dollars, as big as maybe 50 billion devices felt 10 years ago. And the report does a great job explaining, where this technology is going and how it's being used, but the simple summary here is that it's going to be everywhere. It already is. All those embedded processors that have been proliferating for the last 20, 25 years are the first candidates to connect. We don't have to go out and build entire supply chains with electronics and PCBs. It's already happened. Light bulbs have moved from filaments to PCBs. That's just an example. Shelf labels are already being adopted with e-paper displays. And the way this technology is being utilized by our customers is across efficiency, safety, security, lower insurance rates, like new use cases, those things that I was mentioning earlier. And we've gone so much further than tracking cats on the internet. That can be fun too. So for 3 examples of this, I'd like to walk through different use cases. First, in energy. Energy sector was arguably one of the first IoT sectors that were out there with the automated meter reading. so people didn't have to walk around reading the meter with clipboards anymore. And it started off very simply here, but now this technology is being spread throughout the entire grid. Electricity is expensive. People need it reliably, and to get the most out of your grid, you have to be able to observe and transduce all throughout that grid. We're seeing it happen in the power distribution networks as well as in buildings. Building automation and building systems now, electricity is one of the most expensive things that they pay for. And they need the ability to identify what's happening and control it at the building level. So we're seeing, from the power plant down to the circuit breaker in your home or your office, these things are being connected today. Second, our understanding of health is about to change. As the technology comes closer and closer to the consumer, which a lot of that happened during COVID, a lot of the technology that was only available in a clinical setting is now being packaged and sold at home. IoT is a big player there. The connectivity in the home and the devices is a big part of that. And we're seeing that health and overall wellness are about to move into a very personalized state. And that's just not been possible before. Instead of going to the hospital and taking your blood pressure, you can take the blood pressure at home anytime. You can read your blood glucose. You can read so many things that you could not ever do before. And so now doctors and healthcare providers are going to be able to make the connections between drug programs, between the drug programs, the microbiota, the environment, the genetics, everything that we've been living with all this time. And something as simple as glucose monitoring is going to move from just saving lives for the insulin dependent into an overall understanding of what our health is, how nutrition and things like that affect our health and wellness. Finally, on agriculture, feeding the planet is one of the biggest things that our world economy is built around. There's more people than have ever been alive before, and it's important that we eat every day. The agricultural sector underwent genetic revolution in the 70s and 80s and increasing crop outputs. Now they're adopting this IoT technology all over the place to further enhance the output of these farms, to ensure high quality through the food supply chain. One example is beekeeping. Every year there are billions of bees that are transported across farms across the world to fertilize crops. One of our customers is inputting sensors in every hive to track the location, the health and wellness of the hive, to figure out if the queen has died or not, and to decide generally how to optimize their operation. These are just 3 examples, but really every industry is adopting this IoT technology to drive the business forward. This is the only way you can get to such large trillion-dollar numbers. And as they do this, as these businesses embed connectivity, connect it to the cloud, they drive their businesses forward, and there's no way back. Once you do this, you cannot undo it. And there's 2 reasons for that. The first one is that an IoT device, a connected device, unlocks value. You're not just adding connectivity, you're creating value in that process. And there's a lot of ways to describe this, but I figured a real-world example might be the best one. Milwaukee Tools is a US-based tool supplier, and they've deployed connectivity and IoT technology throughout their tool portfolio. There's hundreds of tools in this portfolio. And they found that they can do a lot of things that they could not do before. These devices are better. The workers are more productive. Here's how they do that. First, they can optimize the performance of every pull down to the trigger pull on that device. They can optimize the speed, the torque, the duration, all kinds of parameters, and so that you have high quality, consistent output from the worker for the day. Why does that matter? Well, if you're installing a solar panel array with hundreds and hundreds of these panels, you have to be very careful. If you over-torque the screws, the panels crack, microfracture, and over time it brings the yield of the farm down. Well, Milwaukee Tools won tools bids on this by programming the drills to not over torque as the screws set down on the surface. Beyond that, you can do things like tracking the tools, locating them, or preventing theft. So on a job site, building a big building that takes 2 or 3 years, you drop the tools off at the beginning and you pick them up at the end. Over that time period, the tools go everywhere. You don't want to pay somebody €100 an hour to go find a tool that they put down last week and somebody else picked up. In addition, you can lock these tools, unlock codes with Bluetooth on the cell phone every day, and that not only prevents theft, it ensures that only the person who's supposed to use that tool can use that tool. And a lot of specialized tools are very dangerous. You want to make sure somebody doesn't accidentally hurt themselves. The sensors in these tools can also identify if it's going to break down. So it can alert the user that this product needs to be serviced. So it not only prevents unplanned downtime if the tool breaks or damages the equipment that they're using, but it actually extends the lifetime of the tool itself. Last, these tools can log, data log. So there's a lot of logging and proof when you're doing building for certification and inspectors. Like when you're connecting high voltage power lines with each other, you have to crimp them for a certain time period, a certain duration. And the tool can actually log that, and when the inspector comes, you show them the logs, and it gives them more proof that you actually did the job well, so it's higher quality. So these devices, once they add connectivity and more processing, become more valuable. And as the businesses add more and more and more of these capabilities, they're more and more reliant on the data flow back and forth between between the device and the cloud. And once you have that, and your business model is based on data, you can't go back. No business today can survive without a significant presence on the internet itself, as an example. Marketing, sales, customer support, contact information, these kind of things. Much of the whole first internet was developed around the concept of connecting people to businesses. That's really the IT infrastructure of the world. Well, there's a new internet, a second internet that's being built that's going to be many times larger than the first one. And it's not about people, it's about things connecting to things. It can be 50, 100, 1,000 times bigger than that first internet. So the IT built around people is turning into OT, operational technology built around these devices. And here's some examples of that. The retail sector is undergoing a big change right now. They're adopting a lot of technology in the stores, in the warehouses, in the supply chain, and one example of that is electronic shelf labels. Something as simple as replacing a piece of paper with an IoT device transforms their business. These shelf labels make workers more productive, because they're not changing the price on the shelf label. That's not very high-value work, so they can do other jobs. The businesses have the ability to update prices on a more regular basis, maybe once a day instead of once a week or once a month. You can drive new revenue with coupons and discounts on those prices. You can locate devices on the shelves by flashing. You can put sensors in these shelf labels to detect people motion, temperature in a cooler, these kind of things. There's all kinds of uses for something as simple as replacing a paper display with an electronic shelf label. It makes the business more operationally efficient and can drive more revenue. And all retailers globally are adopting this right now. Second is in transportation. This idea of where is my thing, where is my stuff, is not a new one. People have been tracking products through the supply chain for a long time, but maybe you can only afford to track the highest value products, or maybe only check once or twice. But as the technology barriers come down, as the cost comes down to do this, people are able to track their devices from beginning to end at any moment in time. When you have that information, you can optimize the entire supply chain around this, knowing where your things are, what's the status of them, who has had access to them, the traceability. All this data becomes very valuable in an operation like transportation. Third one is in security. One of the biggest challenges, or there's many challenges in security, but one of the biggest challenges is false positives. And people are deploying IoT technology with a lot of edge intelligence and connectivity to detect the difference between a dog and a person, or a door slamming and glass breaking. When you have lower false positives in the security world, you have safer products, you have less wasted time, and overall lower costs. And as industry after industry adopts this technology, we're seeing the products go almost literally everywhere. And that sounds maybe like I'm exaggerating, but I really see it everywhere. We see it in mining, the deepest places in the earth, they're using this. We see it in space with the new satellites that are being launched around IoT connectivity. We see it in our homes and our offices. We see it everywhere. And as many processors are being shipped, we're seeing as many IoT devices. According to ABI, 11.5 billion products will ship this year, bringing the global total to anywhere between 35 and 40 billion units. Not far away, again, from the 50 billion units that Ericsson predicted a long time ago. This is just a few examples here in home automation, inventory tracking, lighting, light bulbs around us, big market, health and fitness, building automation, and medical. You know, the global market, when you think about how do we get to tens of billions of units a year, has to be pretty big. These products have to go pretty far and be accessible to almost anybody, even cats tracking on the internet. And so when you view it through these lenses, you can begin to understand how the IoT technology can be a real pillar of the overall global economy. So that brings us to now. You know, we talked about why it's happening and what people are doing with it and the impact it's going to have. But we have a long way to go. And I'm actually very happy to say that. You know, the generation is going to change this. And in many ways, the phones haven't changed a lot. Kind of saturated here, but in the IoT, it's going to be a lot different in 10 years than it is today. So it's a very exciting time to be an engineer in this space. And in my research for this talk, the same 4 things kept coming up. Well, many things come up, but there was a top 4 of what we need to do together to take this to the next level. And I've invited a few speakers to come on stage with me today to talk about what those are. And it's vital that all of us and the entire IoT supply chain, from chip suppliers and IP suppliers all the way through cloud integrators, take these seriously. So I'd like to invite my first speaker talking about accelerating software. His name is Paul Williamson. He's the Senior Vice President and General Manager of IoT Products at ARM. Thank you, Paul.
Thanks, Daniel. So thanks, everyone, and it's a great talk, and I totally empathize with that history, but also with the future opportunity. At ARM, we're working to develop an ecosystem that covers everything from the tiniest little sensor that we mentioned through to really quite high performance and sophisticated devices of the future. Every day, millions of people build products based on the technology we develop at ARM. And that's why we work with important partners like Scilabs, because together, we can ensure a consistent developer experience that can really allow that scaling that Daniel has talked about. Now, one of the things that's clear when you look at some of those use cases and the timelines is that we need to be in this for the long term together. To develop the return on investment that you need to transform industries requires that consistency. And while hardware is exciting, a lot of the future challenges are about software. If we're going to bring workloads from the cloud to the edge to these devices, we need to upgrade the way we think about our developer flows. And for me, a key area there is the deployment of real-time operating systems as a foundation for the development of software and embedded devices. It changes the game. It makes these products scalable. It makes them maintainable, portable. You can deploy them more widely than ever before, and you can keep them secure. And RTOS provides you that consistent underlying framework, and it's going to allow you to connect these devices to a range of clouds. So Azure, AWS, whatever you need, you can have those consistent developer APIs for the connectivity. It also provides that essential fundamental capabilities that are needed to put a product out there and deploy it for 25 years. You're going to have firmware over-the-air update. That gives you that long device life. It's crucial if we're going to maintain security of devices and also meet the regulatory burden that we're going to see emerge when we're so important to these global ecosystems. So for me, the next generation of these IoT devices that we're all so excited about building are going to have to take the best practice of software development flows from across the industry. And we're going to deploy them first and foremost in IoT. We're going to enable embedded developers to engage with those modern DevOps workflows, and the techniques that they need are built on this foundational need for RTOSs and common APIs for consistency across that ecosystem. Thank you.
Thank you, Paul. I always talk to my team and I say, the cloud doesn't interface well with bare metal. And when you say it that way, it's pretty obvious. It has to be OS to make this work. And in a lot of embedded systems today, we're still seeing, believe it or not, in 2023, a hesitancy to move forward with real-time operating systems, even on the smallest devices. And as the barriers have come down, now we have the raw compute and memory to really support that. So thank you, Paul. So for my next speaker, this is one near and dear to my heart, and I've been working on this a long time. It's really about securing your products. This is absolutely foundational to get where we're going, and I'd like to invite Sylvain Guillet, co-founder and CTO of Secure IC, to tell you why.
Yeah, so 50 billion IoT devices, you see, deployed. This cannot work without trust. And the root of trust, actually, is the cybersecurity. So let me, in 1 or 2 minutes, decrypt what is cybersecurity in the context of embedded devices. First of all, it is a solid foundation. Chips must be secure, protected against physical attacks. You don't want, someone to read your data within the chip, okay, to tamper with it, maybe to conduct some other memory reading attacks, okay. And it's also a way to securely connect to the cloud using protocols that have been vetted and using technologies like key exchange, authentication, encryption, end-to-end. For the value of IoT is the data. The data stems from the device, and you want end-to-end secure connectivity from chip to cloud. Okay? So today, what can you rely on? Hardware platforms that are already made secure by design for you, and then the ability to write software to manage your data and your assets through their life cycle. From the beginning, where the data is created, when it is computed inside of the chip, and then when it is uploaded to the cloud. And at the end of the day, this enables the ability to certify your solution, hardware, indeed OS, and connectivity to the cloud, using schemes that will enable even more trust to the market and to the end users. This goes through some certification schemes that are really important because actually it is a third party, validating your security. So today, here we are, secure chips, secure connectivity, but we have a roadmap in front of us. So Daniel and us at Secure IC believe that, you know, there will be even more progress. Data will be encrypted everywhere, even in the chip. This needs to be done with power efficiency. And we have in front of us also the challenge of adapting to the new cryptography, namely the post-quantum cryptography. That's our challenge for the years to come. Thank you.
Thank you, Sylvain. I mean, this idea, to build off that, is that I don't care what it is, how low cost it is, how low power it is, we should be able to have roots of trust. And I always say that the IoT will run on trusted software. I mean, this idea that embedded will somehow be different, that it won't have to run authenticated code, is going to pass by the wayside. And over the next 5 to 10 years, we'll see it go from small percentage to probably 100% of software that's running globally into this trusted software model. I'm really looking forward to that. My third guest that came in, I asked him to come and talk about nothing about technology at all, but really about our teams. And he couldn't be here today, so he submitted a video here. But there are two kinds of teams operating in most companies today. Device teams building the physical products that companies like Silicon Labs will sell a chip to, and then a cloud software team that then manages that device over its lifetime, sometimes as many as 5, 10, or even 20 years. And so I asked Darren to talk about, he's the CTO at Acre, one of the world-leading building access companies, and I asked him to talk about connecting these device teams with cloud teams. We've got to do that better.
Many of us are building embedded devices connected to some cloud or other. It naturally leads us to have teams that are apart, a cloud team and an embedded team. Those cloud teams have great tools and technologies for visualizing their code and how their code operates, and for finding bugs and generally deploying great things. In the embedded world, we're less covered in general. The tools aren't so great, our visualization tools aren't so powerful, and we're caught in a fight between the cost of the device that we're trying to create and the amount of processing power and memory that we give to those developers. We want to maximize our profits, and so we choose tiny, constrained processing devices and as little memory as we can get away with. And that drives our developers to develop in what we call bare metal. That's right down at the lowest level. And let's face it, engineers aren't the best at documentation, and that means months or years later, you need to do an update for security or for a new feature. That becomes hard and takes too long. My urge to you is to get enough horsepower in your processors to use an RTOS. Give the developers enough memory so that maybe they can even containerize their embedded development. If you have an RTOS and you have a powerful enough processor and you containerize your code at the embedded side, then you naturally get better tools and you naturally bring the embedded world and the cloud world together. Bringing those two teams together is huge. You will get a better system. The cloud team can talk to the embedded team in similar languages and get a system that works cohesively. So do yourself a favor. Give the embedded teams an RTOS. Give them more processing power. Give them containerization. Bring the teams together to create a fantastic system.
Connect teams together. Oh. Darren says thank you. My last guest also could not be here, but it was fantastic on the interviews. His name is Juan Sequeda. He's the principal scientist and head of AI labs at a company called Data.World. This is a company that makes its life on being the clearinghouse for data for companies going forward. And I asked him to speak about empowering data governance. We're here because there's all this value and all this data in the IoT, and we're collecting it in massive amounts, and it's just growing year by year by year. And so the question is, what are we doing? How are we managing that data? Are we using modern ways of looking at data governance to get the absolute most we can? And many times there's a simple use case someone's trying to enable with this data, and there's so much more that you could do with that. And good data governance will get the most out of the data while protecting the company or the organization against the bad uses. There's bad ways data can get out. There's a lot of private information there. There's a lot of certification and compliance, regulations built around this. And as the IoT takes step by step forward and collects more and more of the data and becomes more rooted in the global economy, I'm urging all the companies from anywhere you are in the value chain to empower data governance. I know we're doing this at Silicon Labs, and I hope other organizations are doing it as well. So if we can do these 4 things in a big way, as big as all the chips and use cases that we've worked on the last 10 years, I think this is really going to get to those trillions of dollars impact to the global economy that we've been talking about. So taking a step back, here we go. We've come a long way in this space, but we have a long way to go, and it's bigger than I ever thought it could be. Thank you for your time today, and I think we have a few moments for questions.
Yeah, super. Thank you very much for this excellent keynote. Oops. And really sorry. Thanks again for this excellent keynote, not only from you, but also from the others. I believe it's very important also to show the ecosystem behind. And of course, we would love to use the opportunity having you here for asking questions. So we have a microphone here, and he would be so kind to run around. So if you have a question, please raise your hand, and the microphone will run to you. Otherwise,
especially if you have a hard question.
Yeah, maybe I start with an easy one. What is the biggest challenge that you as Silicon Labs face in this ecosystem?
What is the biggest challenge Silicon Labs faces over the next few years?
Let's say the decade that we discussed earlier.
The decade? I think wireless is still too hard to use. Not because Silicon Labs is doing a bad job, but because most customers aren't wireless experts. And so I think we still need to do more work to make wireless as easy to use as a processor is. Anybody can use a processor. I need anybody to be able to use wireless. So we still have some work to do there. Probably the second biggest thing is just our customers moving from proof of concepts to wide-scale deployment of IoT. There's going to be some challenges in there that we have to solve together. That was too easy.
This gave you some time for thinking. Okay, then maybe the second question in this context: what do you expect would be the challenge in 10 years' time, after, or maybe after 5 years after these? Well,
AI, machine learning. So there's a question right here, but as we see the inference models built in cloud and for phones and computers and automotive, it's going to move into embedded too. We already see this with simple things like wake words, but there's going to be very sophisticated machine learning on very small processors in the end, thousands of times better than it is today. Maybe not utilizing traditional digital techniques, maybe more analog techniques. I have a lot of opinions on that, but I'll probably be wrong on most of them. So I think over a 10-year time frame, how is machine learning and AI going to infuse itself throughout the IoT is going to be a big question. But I do know you need that wireless and need it secure, because no one's going to trust it if you don't have those things.
Super, thanks.
And there's a
yes, please go ahead. Mm-hmm.
Hi, this is Satyajit from IoT Analytics. The industrial IoT is still heavily dependent upon wired, and that is the one aspect I think it is still tough to crack the wireless from a wireless perspective. How do you see the adoption of wireless technology within the industrial IoT?
Great question. Industry 4.0, and is wireless being adopted in industrial settings? Yes, we do see that. We organize our business around home and life and industrial and consumer. We have dedicated business groups just following the industrial side. In fact, the leader is sitting right behind you. We're seeing wireless technology move from a state of mistrust into more trusted right now. We have a customer I was talking one of the engineers on the way over here about who's replacing cables within their factory now with wireless links, and something that 10 years ago they wouldn't have done. So I think over time, as wireless moves more from a consumer mindset into new standards that are built for more robustness, high quality of service, we're going to see a lot more wireless deployed because the benefits are just so high. And in many cases, the ROI is so great, actually, in an industrial environment. There was a question right here in the front. But industrial is one of the slowest moving segments as well. They're not going to adopt it quickly, but we are seeing it in big volume now.
Hi, I had a question about public perception of data privacy with IoT devices. I mean, what are you guys doing to ensure that the public don't feel their data is being sold for profit and not just for their use cases?
Yeah, so what are we doing in IoT to protect data for the consumers? We sell chips at the very bottom of the supply chain. I can't control what my customers do. What we do is provide a way to make sure that the software running on these chips is authentic, it's authenticated, and that encryption down to the smallest device is very possible, and a secure supply chain behind that to deliver these secrets into those chips. So we're providing the tools for companies to do whatever they want here, and so they've been there for a while, and we're starting to see a lot more pull for this than push, which is a really good sign. But there's a lot of misconceptions out there that security is too hard, or it's too expensive, or it's too easy to get it wrong. And that's just not the case. Maybe it was 5 or 10 years ago in an embedded environment, but today we have secure enclaves in these chips. We have secure supply chains to get the secrets in and out, and we're seeing a lot of customers start to pull for that. So I'm hoping they adopt this in more and more volumes so that we can protect that data that's out there.
There's one more question here in the front.
Yes, you said it beautifully that embedded systems are quite of a recursive process. You said the more embedded systems exist, the more there will be in the future. Where do you think this system, this recursion might end, or maybe it should end eventually? Great question. How big is this going to be? And embedded computing is just going to turn into connected embedded computing. I think that there's not much end in sight. And I look at companies that are predicting trillions of units with things like simple passive RFID tagging, things like that, in tires, in auto part supply chain, in medical, all the drugs that are moving around medical, or consumer packaged goods. Why not on every single box? I don't see a limit in sight. I think the MCU markets and the MPU markets continue to just go. We're seeing growth in 8-bit. We're seeing growth in 32-bit. It's still on the rise. Companies like ARM had a big play to that to kind of level the playing field there and make common tools. And if we can bring those tools into kind of a cloud-connected tools, like what Darren was talking about, it's going to initiate a whole new wave of this because the companies need it more. They're going to want to put more, now that they can see that their operations from the cloud, they're going to try to put more of that technology into the real world, the same way that IT started from data centers and put computers in all of our hands. It's the exact same thing, only on a scale that's maybe 1,000 times bigger, in my opinion.
Hi there. You talked about the billions of truly wireless devices. One of the challenges there is how they're powered. How do you see the trade-off between, for example, battery-powered or energy harvesting, the lifetime requirements?
Yeah.
What's your view there?
Fortunately, a lot of the batteries in the world are about to disappear. Energy harvesting is starting to get to a cost point where it makes sense to put in something like this clicker here. So powering all these MCUs on the planet is not an easy task. Just like powering all the things in this room is not an easy task. For everything you plug into the wall, there's maybe thousands of them that you don't plug into the wall that are powered. So I think that if you need a battery, you'll have it available. We'll see if regulations start to try to make that cleaner. But the automotive industry is doing more for batteries than I think anything ever before.
Like what data centers did to, or cloud computing did for the IoT, we're seeing automotive kind of do for chemistry these days. And then the energy harvesting is starting to come into economical sense. It's always been out there, but we're starting to see it more and more and more in small things. We're already at the point now where we can have small coin cell batteries that last 10 years in an application. So powering the IoT is not an easy thing to do, but fortunately there's a lot of technology that's about to hit the market there.
Okay, super. Thank you very much again for the excellent keynote. Also to Paul and Sylvain for your contribution, and well, to Devon as well.
Thank you.
Thank you.